Hey friends, this week we're learning about the Earth's rotation, day and night, and shadows. We're going to read a page from the Stemscopedia article about Earth's rotation, and you guys are going to make Cornell notes today. When you click on the assignment, you can get to the PDF of the article by clicking Open Assignment with Cami. You can make your Cornell notes with paper and pencil, and then upload a photo of your notes. So this video is going to be me reading through the article with you and kind of giving you some hints and tips about what is important to write down. My suggestion is that you pause the video as we go to give yourself time to write. Don't feel like you need to write at breakneck speed in order to keep up with me. Earth's rotation. Reflect. In ancient Greece, people believed that powerful gods were responsible for all things that happened in nature. The Greeks believed that Helios, the sun god, drove his fiery chariot from one end of Earth's sky to the other each day. His daily trip caused sunrise in the morning and sunset in the evening. At night, Selene, Helios's sister and the goddess of the moon, made her own trip across Earth's sky. Today, scientists know that these stories are only myths. Do you know what really causes sunrise, sunset, day, and night? Okay, pro tip. This whole first section of the article is really meant to be what writers would call a hook or something to grab your attention and make you think about the topic. None of this first paragraph is factual information that you're going to be tested on. So it's interesting to read, and it's definitely useful to learn about history, and it helps make a picture in your mind, but you don't need to include this information in your Cornell notes. How often does the day and night cycle occur on Earth? Stop and think about what you already know about the topic. I bet you can already answer this question without reading the article. How often does the day and night cycle occur on Earth? You probably could tell me that day and night occurs every 24 hours. Okay, let's read and learn more details. Earth moves through space in several important ways. One type of motion is called rotation. A rotation is a spin around a center. This is something important that you need to write down. So write down the word rotation in your Cornell notes and record that the word rotation means a type of motion or a spin around a center. For example, imagine a spinning top. Earth also spins around a central line called an axis. Earth's axis is an imaginary vertical line that runs through the planet from the North Pole to the South Pole. This is something else important that you need to write down. My suggestion is that you write the word axis in your notes, then write imaginary vertical line that runs through the planet from the North Pole to the South Pole. Next, I suggest drawing a picture. Let me see if I can show you what I'm envisioning. So I would say, actually, is this the pen tool? Let me see. That's a highlighter, box highlighter. Pen? No. Oh, there we go. Okay. So I would say draw a circle. This represents the Earth. Draw the imaginary vertical line described in the text. It runs from the North Pole, which we can label North Pole. Forgive my handwriting because it's very difficult to write with this tool. North Pole. And then down here we have the South Pole. Now, we've learned in previous science lessons that the axis does not actually go in a straight vertical line. It's slightly tilted, and it says that further on in the article. So I probably should have drawn it more like this, actually. I wonder if I can erase. There we go. Okay, so this is the Earth's axis that I've drawn. An imaginary vertical line, slightly tilted, that runs from the North Pole to the South Pole. And then they continue on to say that, let's see if I can get my spot back. Earth's axis is an imaginary vertical line that runs through the planet from the North Pole to the South Pole. If you held a globe, by putting one finger at the North Pole, up here at the top of the globe, and another finger at the South Pole, the invisible line that connects your fingers represents the axis. Earth's axis is slightly tilted at an angle of 23.5 degrees. This is something else that's important for you to put in your notes. The angle, if you measured the angle between what the axis would be if it ran straight up and down and the tilt that it's at, this angle here that I'm kind of highlighting in green, this angle here is 23.5 degrees. So I can record that here. 23.5, 0.5 or 5/10 represents 1/2 degrees. I'm kind of using the highlighter tool to keep my place in the text as I continue reading. Because of this tilt, different parts of the planet receive different amounts of sunlight at different times. As a result, Earth experiences the different seasons of spring, summer, autumn, and winter. I would say that those are two important facts for you to record. I want you to record that because of the tilt of the Earth's axis, different parts of the planet receive different amounts of sunlight at different times. As a result, Earth experiences the different seasons of spring, summer, autumn, and winter. In other words, would we have seasons if the Earth did not have that 23.5 degree tilt? No, we would not. As you read this sentence, Earth is rotating around its tilted axis at a rate of 1,000 miles per hour, which is the same as 1,609 kilometers per hour. This is something that you guys made a prediction about yesterday in your assignment. I asked you to make an estimation about how fast you think the Earth spins on its axis. I'm curious, was your estimation anywhere close to accurate? I'm not sure I could have come up with an accurate estimation for this. It's because it's hard for our human brains to visualize that speed because we can't feel the Earth spinning. Okay, let's keep reading. Why then does it feel like Earth is standing still? In comparison to humans and other things on Earth, the planet is incredibly huge. Because of this difference in size, you cannot feel the speed of Earth's rotation. We know the planet is rotating, though, because we see the effects of it every day. Okay, so this is another important fact to put in your notes. Let me highlight it for you. Because of this difference in size, meaning because of the fact that Earth is huge and people are small, you cannot feel the speed of Earth's rotation. If we were huge giants, more similar in scale to the size of Earth, we might be able to feel the spinning Earth a bit more. But we do know that the planet is rotating because we see the effects of it every day. Okay, finish up your Cornell notes for this article and submit them to me. Let me know if you have any questions.